Hello everybody! So today we are watching a race. We are playing Flamme Rouge and each colour represents a bike. The bikes are trying to get to the finish line first. The finish line is the ones with the arete here, so everything past here is that. Teams 2 and 3, the blue and the purple, they are playing random cards. Team 1, the green here, is playing their highest card they have. And Team 0 is trying to take account hills and is otherwise playing a breaker strategy. That is, they'll play random cards until the last 20 spaces and then start playing their highest cards. None of these strategies are particularly good. There are definitely better strategies out there. And today I want to try and write some better strategies for our racers. So I kind of need to explain a few of the rules. So every racer has, they start with 15 cards and they draw 4, pick their favorite. They play that, discard the other 3. The card they have picked will never be used again. They have numbers on from 2 to 9-ish, depending on the kind of racer. We have a sprinter or a rouleur. The rouleur being kind of a pace setter guy. The rouleur has steady paces. He's got the numbers 3, 4, 5, 6, and 7. So he can choose any of those speeds. Whereas the sprinter has 2, 3, 4, 5, and 9, so he can do the faster speeds, but he also goes slower. Once you've all chosen a speed, everybody moves forward at roughly the same time. It does the front racer first, and everyone else moves forward, which avoids collisions and any confusion. If there is a gap of exactly 1, just as OR did there, they skipped forward. If there's a gap of exactly 1 between your racers, they will slipstream unless there is an uphill involved, which is represented by this red area. So when these guys get out of the hilly area, we should see some slipstreaming. So here, these 2 racers slipstream together and catch up there. The front racer from any pack of racers will also receive some exhaustion cards, and that's being labelled down here. At least 1 racer is going to get exhausted every single time, and those are just 2s that clog up your hand and limit your choices. If your racer starts on a downhill, they get a minimum speed of 5, so even if you play a 2, they're going to go at 5. And if they're going to touch an uphill in any way, they have a max speed of 5 and there is no slipstream. So that's the basic principle of how this goes. First racer to reach this section here is the winner. So we are watching 5 races. Once the 5 races have finished, we'll get a final score, see which style has done the best, and then we will get to trying to code a better strategy. So the final results. The racer who has done best in this set is 2R. But the pink and blue strategies both did best. Now those are the random strategies, so that's not ideal. I did actually play this like 1,000 times before doing this, and the red strategy was able to win about half of the races. So that's definitely better than 1 in 4, and definitely better than the numbers that have come up here. So in this file, I have defined the strategy trait, the strategy being it has a select card function. So you're given a rider, a set of cards. It should be 4 cards, but there are occasions where it's fewer. And you are given a track, the picture of the track. One of the things that's nice about Rust is you can just give them a full view of the track and know that they can't change it and cheat, right? So obviously I trust you guys completely, but if I was to let you guys write the strategy, I'd far prefer if you couldn't just change the track as you wished. That doesn't feel right. So all you're allowed to do is receive a set of cards and you choose the index of the card you prefer. And there's another function called strat name, so that when the function runs we can define which strategy has won. And that's basically it. So here is the random strategy. It does take the rider, but it doesn't care what the rider is. It does take a list of cards, but it doesn't care what the list of cards is. It does take a picture of the track, but it doesn't care about the track. It just returns 0, choosing the first card it was given. It's going to go through the cards, choose its favorite card, and then return the highest of those cards. And the only case where this max by key fails to return something is when the list is empty, and in that case I'm just returning 0. We should not get an empty list, and I have actually put in the main code a catch so that if the list is empty it throws in an exhaustion card, which is exactly what the rules of the Flamme Rouge game are. And yes, strat name is highest. Now the breaker strategy, which currently didn't actually run in the code, this is the original breaker strategy. It basically reads the distance to the end of the track. Now I was actually tempted to try and test breaker strategies with different values, so we could actually do that. So make a breaker strategy that decides when it wants to leave. So we'll have dist of we've been using usize for this whole thing. The main reason is because that just helps with indexing. So usize is the standard number for indexing, and so actually I've never created a breaker strat, so let's try out a bunch of that's just a plain function. It doesn't belong to the thing because we actually flip to using a breaker strat in the main game. So we'll just have that as a usize, and it's not self.dist because we don't actually have a self. But in here we can put self.dist as the first parameter. So this is the original reason I pulled that out of this kind of rider, was to make the function more available for... The original reason this was separated was because I actually had 2 riders, and I actually had select card for roulette and select card for sprinter, and I didn't take the rider as a parameter. Taking the rider as a parameter actually meant I knew whether it was roulette or sprinter, but I also knew what team it was on, and that meant I could ask better questions of the track. So there is at least one more place where we call breaker strat. Here we are. So we need to set a distance that we think is good, and that was 20, so let's not change that for now. I think this might be one of those things that needs to be flexible to the length of the track, so maybe a stronger breaker strategy would take into account how long the track is before it works out how long it wants to break away for. Even better, where the final hill is, which definitely makes a difference to how you play. So I think it's just the isn't created. So let's add a breaker strategy here. So we'll put a breaker strat, and this one is dist of, and we'll put a dist of 5. Here it is. So for those of you who have been watching me for a while, I have finally got Rust thumped and everything correcting working in Vim, and it is so much nicer to have. Just being told that your code doesn't have all the problems. So I bet dist is private and that's what it's complaining about, yeah. So we come back here, we should make that public. Honestly, I have no idea why I didn't. It was awkward to set up, but the benefits of setting up something that highlights code errors far outweighs the awkward. So if you haven't done that, do that. So let's run this code. We now have a breaker strat running in the middle. Let's speed up. Let's speed up how fast they run as well. So we'll set the delay to half a second, so they should race a bit quicker. So it does movement and then slipstreaming. Right? Move, slip, move, slip. Just so I could that helped me to see whether it was working properly. I haven't caught it doing slipstreaming wrong, so I'm pretty sure I've coded that correctly. So the breaker strat on 10, it's random until the final cards, and that's, which color was that? The breaker strat is the third one, so that's blue. I feel tempted to try and give some race commentary, but I can't talk like a race commentator. There's a whole language to it and a way of just blurring out words that mean nothing. In general, I just value conciseness too much. Say what you want, say it precisely, and then finish saying it. Well, according to this, the breaker strat there did the best, having won 3 other races, but starting nearer the front does help. Let's have a quick test on who should break first. So if we switch these all to breaker strats, we'll have a breaker strat at 20, 15, 10, and set that to 0. It's still going to print it. So 0 means it doesn't bother printing the races. So, well, no. 0 means there's no wait. So it's just going to quickly flash through 100 races. We won't be able to see it, but there we go. There's our results. And out of this one, the best is the rouleur for red. Second came in the pink, which is the exact opposite end of the spectrum. Oh no, there we go. 26 came in for green, for a green rouleur. Green was the color 1, which it is the 15. So we'll use that distance to compete with our new strategy. So it's time to write a new strategy. We've defined what a strategy looks like. So let's just steal a small snippet of code. And this one will be called downstrat, because that one only actually takes into account uphills. Never looks for downhills, and actually sometimes downhill is a good thing to do. So we've got a downstrat. I'm just going to ditch all of this code for now. For now we'll just return 0. Right, we'll fix this, but for now we just got to make sure it compiles, because that helps, so we'll call it down. Right. So it compiles, but it's complaining that things aren't created. We can live with that. Next, we need to get some useful information from the track, which is what is coming next, I think, is probably the most useful things to know. Like, some things to know that are helpful are distance to finish, distance to the next hill and what kind of hill it is, and probably the distance from the next hill, the final hill, to the finish will certainly change some things there. But there was a function I wanted to be able to work with to help with this. I haven't written yet, and that was prefer. Now I think that should be, for now, that shall come in here. I might end up putting another library out somewhere far wider. So this is prefer, and it will take usize, and that will be from So this function, again, it's going to take some kind of iterator over the usize, isn't it? For now, I'm just going to... What's that thing they keep telling you? The greatest sins in programming are premature optimization and premature generalization. Let's just do this as a slice, and if we find that we have a situation where it needs to be some other kind of iterator, we'll use that. So this shall return the index of the let's call this refs, and this should return a usize. We put a 0 there, that should get rid of the error. For p in prefs that is one thing that the Rust bump does. It gets rid of my gaps, and I keep saving with a plan of writing in there, and never mind. Right. So we've got the preferences, and we're just going to see if the preference is in the set. So it's just find if let sum. So we're after the n from the enumeration. We don't care about the value at this point. If let sum n equal, and we're going to take the preferences. No, it's p. No, it's the from. From dot iter enumerate dot find, and on the find we're going to go for, we don't care about the enumeration at the find, we care about the value, and that is that v is equal to p. If we have found that card, we can return n, which is the position of the card. Now, this pattern has two fields. Yes, that's because I'm missing a pair of brackets there. That's supposed to be a tuple. And enumerate returns the tuple, and we're finding on the tuple. Can't compare usize with pointer to usize. Now, which one of these is the pointer? Aren't they both a pointer? Okay. So I'm going to deref that one and see. It's happy with that. Okay. So now we have a prefer mechanism. That means if there is some downhill, we want to land on that downhill because we want to take advantage of its position. Oh, I needed a next track. Let's open up the tab. So track has some helper methods. Like I got dist to hill, so you can choose the kind of hill and just get the distance from your rider to that hill. I could really do with a so this is on. Let's have rider on, and of course this will take self and a rider, and this will return a H. It's going to return a hill. H type doesn't exist. That was the name of the variable in the lower thing. And so in self.rows. So basically the rows, I should explain how, is that still just mismatch types? Yeah. Basically it's a slice of T row, and a row is its hill, which is an enum of flat, up, down or finish, and then the riders are, there's only 2 spaces wide on any piece of track, so the riders, so that's why I used an array. I'm not sure about that decision. That may get changed to a vec later. I think the track, I definitely think Flamme Rouge could benefit from having some sections of track that are thinner and thicker. Some places where you can really fit a third rider, and some places where you really can't. If that happens, I'll try and tweak this code to handle it. Honestly, it's just a bit of a play project anyway. The more helper methods I write, though, the more work that's going to be. If h dot riders I is equal to r, and I have made those comparable, then we return h dot hill. We should always find the rider. I don't really want to make this have to care about finding an error. We'll just return flat. Otherwise, mismatch type again. Not riders. That'll be a pointer. So let's just deref that, and it should match. Oh no, it's an option. Oh, of course. Equals some. Oop. You're kidding. Did I forget to make hill? H.riders. What does it think I'm moving out of borrowed content? I shouldn't need. So this function is never used, but in theory that tells us what the rider is on. Let's return a position as well. So usize hill. And so our return here needs to be well, we'll enumerate. This is D for distance, H should be R for row, really, shouldn't it? Return, and then return D. And that probably doesn't need that now, because we used iter, not iterate. And here we need to return 0 flat. And then we'll have another public function, and this is rider next. And this will take self, and this will be a rider. And again, this will help you if you decide to write a strategy for this. I am going to put this up on Cargo. I'll give you a link. I'll put a link in the description. This is also going to return a use size and a hill. D and a H, no, D on and H on, and that's rider on, and that should be of course self dot. We could just go through the slice, I think, if I understand how this works. We will go for I for DH in self dot rows D on dot dot. That, but if we enumerate that, H dot hill does not equal H on, then we have our result, don't we? So we'll return, so it's in brackets, it's D, which is the distance to the next item, and I need to check some edges there. That's inclusive of the rider's current position, and that will start with 0. Yeah, that should be fine. That should be correct. And then it should be H dot hill. And those implement copy, so that should be fine. Yeah, that should probably be an option. I'll leave it for now. Enumerate found, so I need to actually iterate. Okay. So in theory, that should tell us the distance to the next rider. So to the next kind of hill. So let's improve our strategy. Now this still doesn't take into account any slipstreaming issues, but let's see if we can just handle the hill slightly better. So we've got the prefer method, which is in this bit here, and then we've got the track, which we can get rider on and rider next. So match rider on, and we'll send it rider. We will have a distance, and it'll be hill flat. If the rider is on flat, I might actually leave that one on the outside, so we'll still get a D hill. And in this case, I would just like to very simply return prefer cards, and the slice we're going to send it this time. We'll start with our lowest card, 3, 4, 5. Don't want that, we need hill up, turn, and here on the hill I'd prefer 5, then 4, then 3, 2, then 1. The 1 doesn't exist, and then 6, then 7, and 9 is the and then 6, and 9 is the 9 and 7 don't exist for both riders, so they'll be your least favorite card of all of those. Non-exhaustive, that's correct. Here, I'm not going to do anything here. So that says, depending on what we're on, that's what we would rather do. If we're not on one of those things, I would like to match against what's up and coming. So we will match on track.rider next on Ra. If we have got to this point, we are not on a hill because it will have returned something. We'll take into account the fact it's flat all the way if D is greater than. Actually, we'll just use the breaker strat. And we'll put the distance to 15, we decided, wasn't it? Put the breaker strat to 15, and then it needs the rider and the track, so that will be R and track. But if it's coming up to a downhill, we really want to prefer the distance that gets us on that downhill. D. Oh, and this was going to be hill down. So if we're coming up to a downhill, I want to go the distance that gets us on that hill. So we'll go. I think we need to return that. I guess we can get rid of that and get rid of the return on this one. We'll just make this the final statement. And so here we'll go prefer, and I want to prefer card D, D plus 1. So this is just to get us onto the hill. You know what? Let's get rid of these, because actually if you're on a hill and you're playing a 5, you might as well be playing a 6. Ah! We'll have D plus 2, because actually this is a surprisingly large amount of tracks will handle that. So there is a case that this doesn't handle perfectly, which is of course the case that you've got a downhill leading to an uphill. Well, there are plenty of cases this doesn't handle very well, but breaker strat takes 4 parameters. So what is the other thing? We get the rider, the track. It'll need the cards. And that's non-exhaustive. So let's check out what we do for a hill up. Now the up is less than 9. So oh, we really need one for D is less than 5. If D is less than 5, then we're going to want to use a different kind of strategy here, aren't we? If it's less than 5, we just prefer 5, right? So prefer 5, 4, 3, 2, and then 6 before wasting a 7 on it. If the next is an uphill and that distance is more than 5, prefer D minus 1. Yeah. 1, D minus 2. And it's still not completely exhaustive. In every other case, I'm just going to return 0. And prefer takes an extra parameter here. Okay, so we have a strategy. This still doesn't do anything with our teammates. Now, I like to make it as hard as possible for the strategies that I'm employing. So let's stick on a new one. Box, new, we'll put a down strat here. So, we know who's playing what strategies. I feel like the down should be able to win. That one managed to catch the hill. They both caught the hill on the downhill and got to take advantage of that a bit. Well, they didn't win that race. So, he made it to the hill. He didn't. He must have played a 9 there. There we go. He won that one. There's two distinct groups here that have somewhat made it out. Will they catch them up? There's a bit of distance here. My feeling is probably no. So in some ways it's perhaps playing the hills too much like the hills are what matters, and sometimes the speed actually matters more. I think my general play in this game, I tend to come in late because I've been riding at the back the entire time, and I never get around to overtaking on time. There definitely has to be a point where you make a break for it and just give it everything you can. Like sometimes even on an uphill, for example, which this strategy doesn't really take into account. I think it might be running 100 races here. Yeah, we're not going to watch all 100. Let's get the stats on how many wins we get though. Let's cancel this and run it 1,000 times without any delay. And see if it does get any reasonable level of wins. So the winner is the red rouleur, I think, 273. So that down strat came in at the top. We ran it 1,000 times, and the larger quarter of those went to the red rouleur. In second place was the pink rouleur, who was playing 3, right? 3R, so 0, 1, 2, 3. Just playing a standard breaker strategy. Now I'm gonna call it a day here. Hopefully you found this vaguely interesting. If you have, please let me know, and I'll spend another video trying to actually take into account the positions of other riders. That's actually quite a daunting task to me, but, well, let me know what your thoughts are, and I'll put some links up so that you can write your own bots to race on this track and see how they perform against other racers. I'll see you soon.